Hello everyone, welcome to section 5.3, slope of a line. Now we've done bits and bytes of this along the way, so now we're just going to start to put everything together. Slope is equal to rise over run, but most of us memorize formulas, so there's your formula, y2 minus y1, x2 minus x1. Please remember that the y is on top for rise because the y is in the going up or down section of your graph. We also learned that it could have been put together as delta y over delta x, or it could have been read as the change in y over the change in x, which is another fancy way of saying rate of change. All right, so if I'm given 2 points, G and Q, then I'm going to use the slope formula because that would be the easiest of those 4 methods to be able to solve the problem. Now the idea of using 2 points, basically I call one of them x1, y1, which automatically makes the other point x2, y2. And then I solve. Gives us a slope of -2. Collinear. Are all points collinear? In other words, if I give you a bunch of random points, are they or are they not on a straight line? Now remember, to draw any straight line, you need 2 points, okay? Any 2 points, you take a ruler, connect the dots, there's your line. But to make sure they are collinear, all 3 points or more than 3 points have to be on the exact same line. If they're not, then they're not collinear. Okay, so how do we check this with just being given 3 random points and no graph in sight? Let's take a look. So I used the 2 points from the example above and I drew them on my graph to give you a rough idea. Okay? Then this question becomes, is 16, -21 collinear with my original 2 points? In other words, here's point W. Is it in or is it out of the line? Well, the first thing I would have had to do is figure out the original slope between GQ. And we did that above, so there is your slope. Okay, -2. Now what I do is I use point W with any other point of the first 2. I chose to use G, and I use the slope formula again with this new point. Well, if the slope comes out exactly the same, then yes, point W is collinear with G and Q. Reason? They have the same slope between them. G acts as the middleman. Now, if we try with point Z, 10, -13, it's someplace in between G and W. I would do all the same steps. I use my slope formula. I plug in my G, terms from G, my terms from Z. And you'll notice that when I complete the work, it's still a negative slope, which is what it should be, I guess, but it's -5/3, but not equal to -2, or -6/3. So it is slightly off. So the fact that these slopes are not the same, even so small a difference, it now means that it's no longer collinear. All right, and that is the end of section 5.3. Thanks, ladies and gentlemen.